So this is Geometry, Semester 1. The unit is Rigid Motions. It's unit number 6. The lesson is number 4 within that, called Rotations Practice. It's on CreatorMath.com. Under the Geometry tab, you might need to Google CreatorMath.weebly.com to find the site. The instructions are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. There we go. So here's the site, CreatorMath.weebly.com. Google that, and you should get to this homepage. If you want to know how to fill out the composition book and you have any questions on that, please go down on this page to where you see large letters composition book. Follow all the directions of the videos, follow all the directions of the due dates, and put everything where it belongs, 5 things on the cover, etc. If you follow all these directions, you should have a 90 to 100% on your comp book. Now let's go and look up the notes. Notes, vocabulary, practice problem sets, and videos are all under the tab of the class you're in. So in this case, geometry. This is the PDF with every single vocabulary word on it for the entire year. If you don't have 100% on your Schoology vocabulary practices, then you don't know how to open this document and search it. Just Google, how do I search a PDF for the device you're searching on. Let's go down and find the table of contents for the lesson we're doing now. So this one happens to be from semester 1. Match up the semester you're in. That's step number 1. Make sure you have the table of contents for the correct semester. You should have already copied this entire table of contents into pages 2 through 6 of your composition book. If you haven't done that yet, go watch the video on how to number the pages of your comp book. Watch the video on the example comp books, and you'll understand what it looks like to put this table of contents in. So we're going to go down to rigid motions is the unit. Let's see if we can find that. Here we go. So here's the unit, rigid motions. There are 6 lessons within this, and this is lesson number 4. So go down to 4 right here. Here are the pages, and it's rotations, that's its title. Here are the pages that these notes go on in your comp book. Please don't use this video for determining which pages they are. By the time you watch this video, these pages probably will have changed. All right? Here are the notes. Here are the problems, and the video solution will be linked right here. So I sometimes have to click notes twice to get them to load. This one loaded right away. If you are able to expand it, then it's loaded. This will talk to you about things like the pre-image. That's the image of the shape before it goes through a rigid motion. It will talk to you about, this one's on rotations, so rotate triangle ABC counterclockwise about the origin 90 degrees. It's starting here as the pre-image and rotating counterclockwise 90 degrees right here to its next position, and that's called the image. There are 3 aspects to rotations. About what point is it being rotated? If they don't say, then it's about the origin 0, 0. Because rotations get a lot more complicated for us to figure out. So oftentimes the origin 0, 0 is used just to make that a little bit more amenable to us. So which direction? Is it clockwise or counterclockwise? Remember an old school clock, the hands turn to the right like this, right? That's clockwise. Counterclockwise would be the opposite direction, turning this way. So I call clockwise turning to the right and counterclockwise turning to the left. I hope that works for you. How many degrees we want to know? Usually it's 90, 180, 270, or I guess we could do 360 if we wanted to just sort of play with it a little bit. All right, so this one says, for example, rotate triangle ABC clockwise about the origin 180. Now 180 degrees doesn't matter. If rotating 180 degrees, does the direction matter? No, because if you go this way, you end up here, and if you go this way, you end up here. It's the same direction. It's the same amount in both directions, so you end up in the same location. Notice triangle ABC. Notice this is triangle A prime, B prime, C prime. Almost always notation starts with the pre-image being ABC, and then the image, where it is after it moves, or after it's experienced a solid, a rotation in this case. then that's when it gets the tick marks or primes on the letters designating that's the ending position. That's the typical way to denote the shapes that we'll be dealing with. So clockwise is rotating to the right, like the hands of a clock. Counterclockwise is rotating to the left, opposite the hands of a clock. And I know a lot of students nowadays, believe it or not, I get it. You don't even see clocks with hands anymore, but you're going to have to look it up and figure it out because we use these words clockwise and counterclockwise based upon old school, I think they're called analog clocks, right? So the origin, remember, is 0, 0 on a Cartesian coordinate graphing system. Remember that we have 360 degrees in a circle by definition. And there's some problems here for you to put into your comp book and solve if you can. Now let's go to the problem set for this lesson and see what they're asking us. So they start out with some basic questions. What is the pre-image in relation to rotations? That's the image before it's rotated. It's called the pre. Pre stands for before, right? Pre-image. What is the image? And it might have been helpful to put some quotes around these, right? What's the pre-image? What's the image in relation to rotations? The image is the image we have after it is rotated. So pre before, image after. And if we use, for example, it says, how is the following notation spoken? There's an apostrophe here, so there's A and A prime. This is called a prime, so A prime. And you can, just so you know, you can have a double prime, you can have even a triple prime, and it gets a little messy if you go too many more. But they're called prime, and this would be B, and this would be B prime. Fair enough? Given the following graphic, about what point is the shape being rotated? So this is nice. I mean, they're even spelling things out here. This looks like it's being rotated. See how this is A, B, C, and then see the primes here? So this looks like the pre-image, this looks like the image, it's going this way. Looks like it's being rotated counterclockwise 90 degrees, and it's definitely about the origin. If you look at this clock of a hand going here to here, these are 90 degrees right there, between here and here, right? So 0, 0, the origin. If they don't tell you in a problem, just assume, unless I guess that's the question of the problem, but if they're telling you to rotate and don't tell you about which point to rotate, you can almost always assume it's the origin. Given the following graphic, about what point is it being rotated? So this one's hard to see, but they literally gave us a point right there. So if they're going to designate a point, right? Oh, and they even came up with the measurement. So this is hard to see. I'm sorry, you guys. It's 1 to the right and 1 down. So 1 minus 1 is this point here. This is 1 to the right and minus 1 down. Okay. Given the following graphic, about what point is it being rotated? So this one, again, they're spelling it out for us right here. Right? So if they spell it out, this is 1 and 1, 2. Yeah, 1, 2. All right? So 1 minus 2 is the location of this point right here. Given the following graphic, in what direction is the shape being rotated? I appreciate that. So this is ABC, and then it's going to A prime, B prime, C prime. So this is counterclockwise. And I'd say the other thing is to the left, because it's starting here and it's going this way, right? Counterclockwise. Maybe you have to Google, what's a clock look like, right? Because I had students even years ago, they never actually learned how to use clocks with hands. They learned with digital, and that was all they knew. So it's totally plausible. It looks like they're giving, oh, here's the point. Now they're saying, given the following graphic, which direction is the shape being rotated? Well, they don't give us any ABC and then A prime, B prime, C prime, so we don't have that clue. But because it's exactly 180 degrees, I think the answer is it doesn't matter. So either clockwise or either counterclockwise or clockwise with a rotation of 180 degrees. If it's 180, you guys, it doesn't matter which way you rotate it. So we don't know, and we don't care. Kind of a trick question, I guess. Given the following graphic, which direction is the shape being rotated? Well, here it is here. They're telling us straight out it's counterclockwise. How many degrees? So this one's interesting. A, B, and C. It goes 90 degrees. This is actually the very first problem we looked at. So it's got to be 90 degrees counterclockwise. So notice three things. What's the point about which it's being rotated? Which direction is it being rotated? And how many degrees is it being rotated in that direction? Those three things are required in most cases for us to figure it out, with the exception of maybe the 180-degree rotation where we don't care which way we rotate it to get it to that place because it'll be the same either way. So how many degrees is being rotated? This has got to be 180 again, right? Given the following graphic, how many degrees is the shape being rotated? So, I mean, let's try to let's pick this point out here, right? Pick a point. Let's take a line directly from our center of rotation here and here. Does that look like 90 degrees to you? It does to me. And we're not going to deal with, I'm not going to rotate something 89 degrees in a Geometry 1 class. It's just, it's a waste of time. Just stick with 90s, 90, 180, 270, and 360, and students will totally get the idea of what a rotation is, right? So make sure you're matching up the title of this video with the actual problem set you're doing so that you can match up the problems. This is Geometry, Semester 1. It is the unit on rigid motion, 06, and it is the lesson 04, rotations practice, and it's on CreatorMath.com under the Geometry tab. Hope this helps.